Hello everyone, welcome to today's video. And for today's video, we'll be dealing with distance, time, and speed. And distance, time, and speed is something that you're familiar with. It's under the rate, work, and mixture problems. And you'll find this under the algebra realm. So we'll be dealing with some notations and some equations here and there so that you can solve for distance, time, and or speed. I believe you're all familiar with the topic since it's tested in our elementary education. So this should be a fun and exciting video. I am Clifford Mwenda, a GMAT trainer with the Kenya Lift program. And so without much further ado, let's look at the definitions. So first, what is the distance? The distance an object travels is its average speed multiplied by the time it takes to travel that distance. That is, distance equals to rate times time. So distance equals to rate times time, or people say it's speed times time, either. So distance is equals to speed times time, or distance equals to rate times time. Rate times time. So how many kilometers did a car travel in 5 hours? This is the time. You asked about the distance at an average speed of 64 kilometers per hour. So this is the speed. What you know that is distance equals to speed times time or rate times time. And already have the speed equals to 64, then time is 5 hours. So that's how we find the distance. Using our knowledge from our trainings, we'll have doubling and halving. This is 32 times 10, which is 320 kilometers. So how many kilometers did a car travel in 5 hours at an average speed of 64 kilometers per hour? It's 320 kilometers. Okay. Now, let's look at something that's usually very tested in the GMAT. It's the average travel speed. So to find an object's average travel speed, you divide the total travel distance by the total travel time and not the arithmetic mean. Okay. So we do the total travel distance by the total, divide the total travel distance by the total travel time. Here's a question. On a 600-kilometer trip, a car went half the distance at an average speed of 50 kilometers per hour. Okay, so we have distance, speed, and time. So we have a car went half the distance, that's 300 kilometers, at an average speed of 50 kilometers per hour, and the other half at an average speed of 80 kilometers per hour. So the other half is 300 at 300 kilometers at 80 kilometers per hour. You're dealing with kilometers per hour. We're dealing with also kilometers per hour, kilometer trip. So the units are good. So be careful with the units in case you have the meters or centimeters or seconds or minutes. Just be careful with. So to find the time for the first half, that will be distance over speed, since you know that distance equals to speed times time. So the time will be distance over speed. Make t the subject of the formula, so you can have distance over speed. This is 6 hours, and 300 divided by 80, that's 30 over 8 hours. Okay, so instead of doing the average speed of 50, that's 50 plus 80 divided by 2. So you can have 130 divided by 2 and have 65 kilometers per hour as the average speed. You do take the total distance, that's 600 kilometers, and the total time, this is 6 over 1 plus 30 over 8. You can have an LCM of 8, that will give you 48 plus 30, that is 78 over 8. I believe, yeah, since 6 times 8, that's 48. 48 plus 30, this is 78. So you can have 78 over 8 hours. All right. So with that, we can find total distance, that's 600 over total time divided by 78 over 8. So you can have the total, not the total, but the average speed over the whole trip. And the average speed over the whole trip will be 600 times 8 over 78, which can be by 2, 4, by 2, This is 3 because of 6, that's 39 by 3, 200 by 3, 13, and this will be 800 over 13. So you can simplify that, but that's the average speed over the whole trip. I can see 13, 800 divided by 13 is not 65. Okay, so be careful on the wording average travel speed. Okay, so how do we approach these questions? Here's how we approach these questions. First, you draw the distance speed table or distance speed time table, as I've seen here. This more of a table, this one here, this is a table. Then you can populate the table using the terms in form of the other and then solve. Okay, so that's how we approach the distance, speed, and time types of questions. Through the table, if you have two or more people, if you don't have two or more people, you can just deal with the formula where you have distance equals to speed times time. If not, you're dealing with two travelers or multiple trips or multiple, say, leagues or divisions of journey, then you can draw the table and then populate it with the values that you have in form of the other, so you can fill the table and then use this formula or distance equals speed times time to solve for it, whatever you need, and then get the answer to the question. This section, I'd like to talk about cars that are moving in the same direction. That's 2 or 3 cars. Mostly, it's usually 2 cars. And also have opposite direction as well. So I'll talk about 2 cars. Let's have the 50 kilometers per hour car behind a slower car that is 30 kilometers per hour. So let the shorter arrow be the slower car and the longer arrow be the faster car. So what happens here is don't look at the vehicles. Instead, look at the distance between the vehicles. That is the key to answering these types of questions. And for these types of, for this gap here, if the faster car is behind the slower car, you expect the faster car to catch up to the slower car. That means this distance should be decreasing. And what is the rate at which this distance is decreasing? Suppose it's 100 meters, then this 100 meters will move from 100 meters to 0. That's when they meet, or when the faster car overtakes the slower car at a rate of 50 kilometers per hour minus 30 kilometers per hour. That's 20 kilometers per hour. So this is the rate at which this distance between the faster and the slower car is decreasing. Suppose the faster car caught up with the slower car and now it's at the front, now 50 kilometers per hour. And the slower car, that's the shorter arrow, that's 30 kilometers per hour. So what happens with this distance? Your guess is as good as mine. Of course, it increases because we have the faster car now in front. So expect the gap to be increasing. And what's the rate? The same, 50 minus 30, that's 20 kilometers per hour. Okay. So a good way to visualize this is when we have cars moving in the same direction. Usually takes a lot of time compared to those approaching each other, because let's talk about the faster car now, 50 kilometers per hour, going to the east, and the slower car going to the west. That's 30 kilometers per hour. So expect this distance here to be decreasing because they're approaching each other. So the distance decreases at 50 plus now 30, that's 80 kilometers per hour. What happens if now they've already met and now the slower car now continues to the west and the faster car also continues to the east? Now, in this case, also, we add the distances. That's 80 kilometers per hour. So 80 kilometers per hour, but what we have here now, distance is increasing, and it increases much faster compared to the distance increasing when this faster car is in front of the slower car. So in this case, the distance is increasing at 50 plus 30, 80 kilometers per hour. So that's how we approach this question. Look at the distance and look at the rate at which this distance is increasing or decreasing, and measure the distance so you can find the time at which this car will catch up or they'll meet, or some overtaking will happen. So watch out for the distance and the distance between the two cars, rather. Then you have the conversion problems. When you have units that are not the same, and for instance, you're converting from kilometers per hour to meters per second, you multiply by 5 out of 18. If it's vice versa, meters per second, 2 kilometers per hour. Then we do times 18 out of 5, the reciprocal. So be careful with the units because you have to unify the units that you have so you can solve for the question. You can't deal with a question that talks about seconds and another minutes and then do the same values. Be careful with the unit values or the units that are used in that particular question. Okay, so enough talking. We've talked about the definitions of distance, the formula itself, that's distance equals to speed times time. We've talked about the average speed, and we've talked about how to approach the problems. We draw the table, populate the table using the terms in form of the other, and then solve. Talked about the vehicles approaching the same direction, the opposite direction, and also talked about converting to common units so we can solve for the question.
You're watching Success with Bob Mwiti Show, presented to you by Upstech America. Upstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstechamerica.com. Upstech America, we wake you up to the unlimited potential.
Now, let's do the first question. Here's the question. Carl averaged 2 miles per hour on a trip that took him H hours. If Ruth made the same trip in 2/3 H hours, what was her average speed in miles per hour? Talking about the average speed in miles per hour. So let's have a table, distance, speed, and time. So for Carl, 2 miles, H hours. Okay, this is miles per hour, so this is speed, not distance, rather. Okay, sorry. So let's have the 2m on the speed, and then took him H hours. If Ruth made the same trip, now we have Ruth in 2/3 H hours, the same distance. So we can populate the distance in terms of the speed and time instead of having new unknowns. Yeah, as I talked about in this second step in approaching the problems, populate the table using the terms in form of the other. So in this case, distance equals to speed times time. So we expect this to be 2mh, and the same distance, that's what Ruth also covered. So 2mh, and we find the speed. I think we can find the speed. If distance equals to speed times time, with time we'll get to notice that we find speed, distance equals speed equals to distance over time. So the time we don't have to write these formulas down. We'll have this on your fingertips. So you should be fluent with that. So speed equals to distance over time. So distance is 2mh, time is 2/3h. So 2mh divided by 2/3h. The h cancels out and you'll have 2m times 3/2, a factor of 2. And then you'll have 3 times m, that's 3m, which is the answer, choose E. So what was her average speed in miles per hour? That's 3m miles per hour. Okay, that's one of the easier question. Now let's have another question, a problem solving question. Here's the question. Pause the video and then you'll try the question together. Right, so if a car N took N hours to travel 2 miles, car B took M hours to travel 3 miles, which of the following expresses the time it will take car C traveling at the average speed, that's arithmetic mean of those two rates, to travel 5 miles? Okay, interesting. We're talking about arithmetic mean and not the average speed. Okay, it's average, not average speed. So let's have the distance, speed, and time. We have car A taking N hours to travel 2 miles, car B taking M hours to travel 3 miles. Which of the following expresses the time it will take car C traveling at the average arithmetic mean of those two rates? So whatever rate you find here and here, we do the arithmetic mean. I know we've talked about the average speed, but this is not the average speed. We're talking about the average of the rates of car A and car B. Let it not confuse you. So the rates of car A, that will be distance over time, that's 2/n. Distance over time, that's 3 over m. So the average of this is a half of 2 over n plus 3 over m. Okay, to travel 5 miles. 5 miles. So talking about the time, this is what we're finding. Okay, so let's express this in a simpler term. So we can have 2 over n plus 3 over m. Let's have the LCM. LCM should be mn. Then divide us, that's 2m plus 3n. That's how it should be. Then times a half. So expect that's 2m plus 3n all over 2mn. So this is the average, not the yeah, the average of the rates of car A and car B, also the speed of car C. Okay. Now asked about the time. The time is make t the subject of the formula, can have d over s. That's the distance over the speed or the distance of the rate. So we have the distance is 5. So 5 divided by the speed, which is this 2m plus 3n all over 2mn. So you can reciprocate this and have 5 times 2mn all over 2m plus 3n. Okay, 5 times 2, that's 10mn all over 2m plus 3n. So can you find the answer here? That's answer choice A. 2mn, also 10nm, that's the same. 3n plus 2m, 2m, yeah, plus 3n, the same thing. So we have answer A. Okay, so far so good. I believe it's all fun and enjoyable. So we can have the DS questions for some of us who are dealing with the data insights. Also, the problem solving for those doing the classic, which is already faded out by the time this video is out. So in this case, we're dealing with those who have the DS questions in the data insights question section rather. So we have, this is the format of the DS question. We have the question prompt. We can have if x is an integer, is x greater than 0? How many students? These are types of other prompts that you'll be having. Then we'll have statements 1 and statements 2. So you have to find among the statements independently first, evaluate if they are sufficient to answer the question in the question prompt. If not, it's insufficient. If it is sufficient, then yes, it's sufficient. So for the answer choices, they're all common for the DS questions in the data insight section. Answer choice A, statement 1 alone is sufficient. Now we're dealing with this independently. For answer choice A and B, and also D, we're dealing with independently. And then for answer choice C and E, we're dealing with them when you combine them, the two statements. But first, we'll have to deal with in evaluating the statements independently first. So answer choice A, statement 1 alone is sufficient, but statement 2 alone is not sufficient to answer the question. Now this tells us that statement 1 alone is sufficient independently, and 2 is not sufficient. For B, statement 2 alone is sufficient, but statement 1 alone is not sufficient to answer the question asked. So 2 is sufficient, 1 is not sufficient. For D, each statement alone is sufficient to answer the question. So independently, if you evaluate 1, it's sufficient. If you evaluate 2, it's also sufficient. Now, in an instance where you find both questions are insufficient, you'll have to combine the statements. And when you combine the statements, now we evaluate for C and E. See, both statements 1 and 2 together are sufficient to answer the question asked, but neither statement alone is sufficient. So independently, 1 and 2 are not sufficient, but if you combine them together, they are sufficient to answer the question prompt. And lastly, E, statement 1 and 2 together are not sufficient to answer the question asked, and additional data specific to the problem are needed. Combine the statements, they're not sufficient. You have to choose E. A car traveled a distance of d miles in t hours. So we have d miles, t hours, t minutes, rather, at an average rate of r miles per hour. Or miles per minute, not hour. So miles per minute. What is the ratio of d to r? What's d over r? Okay. D over r if you remember the formula, this is D equals to speed times time. So the speed or the rate equals to D over T. So what you asked about is the speed. Not the speed rather, but what you asked here is time, since you're dealing with distance over speed, which is distance also over rate. So you have to find the time or this ratio here. So if you have statement 1 telling you that T equals to 30, then definitely that's the ratio that you're looking for, the D over R, which is also the time. So statement 1 is sufficient. You can have that as possible. So B, C, and E are out. You can have A or D. Now, statement 2 tells us that D equals 25. Now the information, we need the information for R, or actually T, that one gave us. We need the information for R so we can determine the D over R ratio. So not sufficient, and D is out. I believe that's all clear now. That's the end of this week's video. I hope you've enjoyed the video. So you can leave the like, subscribe, and share comments. Let us know what we'd like to do for you for the next coming videos. So have a nice day, and bye-bye.